Assalamualaikum and hi, my name is Noor Munirah binti Muhammad HASHIM and I'm from class CS1435D. This is our video group presentation for our subject MAT300. Before we start, let me introduce my group member first. The first is Noor Munirah Muhammad HASHIM, which is me, Noor BALQIS RIDZUAN, Noor AFIQAH MAT300, NURUL ATIKAH Muhammad ZAIK, and ALYA AINUR IQLIEMA BINTI ADHAR. Every day, we will always have a problem we need to face and solve. For your information, most of our daily problems can be solved using application of mathematics. One of the application of the mathematics that we use is application of Newton's law of cooling. So, do you know what is Newton's laws of cooling? Newton's law of cooling states that the rate of heat loss from a body is directly proportional to the difference in temperature between the body and its surroundings. Therefore, by using Newton's rule of cooling, we can determine how quickly a substance at a given temperature will cool in any given environment, and we can explain how the rule of cooling of an object is affected not only by the temperature differential between the material and its surroundings, but also by the cooling constant of the material. For example, we use this application when we want to estimate how long a warm object will take to cool down to a specific temperature and to determine the temperature of a drink in a refrigerator after a particular length of time has passed.
After finishing cleaning the backyard, Sarah was remembered about her daughter's birthday. On 50th January, which is Anne's birthday, Sarah wants to celebrate her daughter's birthday. So, she decided to make her daughter's favorite food, which is pasta soup. In the morning, she is busier preparing the ingredients. After finishing making the soup, she placed a bowl of hot soup in the dining room. Then, she left the hot soup at a constant temperature of 25 degrees Celsius. After 5 minutes, the temperature of the soup was 72 degrees Celsius. Then, she went upstairs to change her clothes. After that, she noticed after 10 minutes later, the temperature of the soup changed to 55 degrees Celsius. The problems are: firstly, prove that the temperature of the soup at any time. Secondly, find the initial temperature of the soup. Lastly, how long will it take for the soup to cool off to 30 degrees Celsius? Next, we go to the objective of the study. There are 3 objectives in this study, which are to make people understand about Newton's law of cooling, to show people the application of first-order differential equation is quite appealing, and to show people how to calculate and solve problems regarding the applications of Newton's law of cooling in our life.
First step is we have to separate the information that have in the question. First is capital T is temperature of object, Tm is a temperature of surrounding, and T is a time. The second step is apply the general formula of Newton's law of cooling or warming with K as a constant as a formula like above. Next, separate the equation where one side is dependent on capital T, that is temperature of object, while the other side is dependent on T, that is a time. The next step is we have to integrate both sides from what we got on the third step. After integrate it, we got ln T minus Tm equal to Kt plus C. To eliminate the ln, we put exponent on the both sides. And the last one, we got T minus Tm equal to Ae power of Kt. Since the object is cooling down to the surrounding temperature, we need to understand that the temperature of the object will always be higher than the temperature of surrounding environment, where in formula T greater than Tm. Therefore, the simplified equation should be T is equal to Tm plus Ae power of Kt.
At first, we need to find the T0, which are the temperature of the soup after it cooked. And we found that the first temperature of the soup are 25 plus 8 e power of kT. Then we need to find the value of K. When T is equals to 5, then T5 is equals to 75 degrees Celsius. Make it as equation 1. When T is equals to 10, so T10 equals to 55 degrees Celsius. Make it as equation 2. Then we can eliminate the equation that we made to find the value of K. So it is proven that the temperature of the soup are 25 plus 73.637 E power of negative 0.0898 T. To find the initial temperature of the soup, we need to find the value of A by substitute A into equation 1 that we have in calculation question 1. So we got the value A is 73.637. The equation of this question are 25 plus 73.637 E power of negative 0.0898 T. Then we need to substitute 0 into the equation, and now we can know the initial temperature of the soup are 98.64 degrees Celsius.
Question 3. How long will it take for the soup to cool off to 30 degrees Celsius? Based on this question, we need to find the value of T, which is the time taken by the soup to cool off to 30 degrees Celsius. To find the value of T, we only need to enter the information that we have obtained from the previous question into the general equation that we proved in question 1. At the end of the calculation, we have found that the value of T is 29.95. So the time taken for the soup to cool off to 30 degrees Celsius is 29.95 minutes.